All right, clicker time. Thank you everyone for completing this. I really, really appreciate it. Always looking forward to the next batch of students, but getting the last bit of information from you while you're here. So the carbon cycle is something that's come up over and over, sort of in bits and pieces, and then there have been a few points which we've talked about it as a whole. Just want to gauge your understanding of this or your confidence level. Last chance to click in and be counted for participation. Okay. Not as many E's as I would hope, or most confidence. But we're going to test this out. Of course, I'm going to ask you to draw the carbon cycle. If you could get out a note card.
Does anyone want to volunteer? Come squad.
And let's just use one side of the card for this activity. If you need to do some graphs in your notebook, that's fine.
How many iClicker questions were there before the last one? 4?
In the top right corner. And I'd like to ask that this be another quietly and individually activity. For this one, you will absolutely have a chance to speak with your neighbors. But I'm interested in what you can get down with these clues as for what you should be illustrating.
Do we still put our lab thing even though we don't have lab anymore?
Let's go ahead and do it, just so we're in the habit.
Well, where?
Dave has that. Okay, I was just like...
Oh, I'm sorry, just kidding. It's because we're the first one.
All right, students, let's just go ahead and get quiet. I'm going to give you about 3 minutes to try to incorporate all of these things into your note card. So at this point, I'm going to acknowledge that we're quite a few people who are the least confident, but now's your chance with these hints to try to piece something together. Hopefully you can move up maybe a level. about 2 more minutes to work on this. I'm going to ask you to chat with the people around you. Hopefully, there are some varying confidence levels. When you start meeting with the people around you, I would like you each to take a turn, showing off your card so each person in the group will have a chance to speak. And then do your best to find something from one of your group members that you can add in. You can also discuss a term that may be up here that you don't have and decide where to place it. So go ahead and identify some group members and let's get real loud in here. 3 or 4 people.
What did you do? Hey, Dennis. I just copied that. You know what I have. I know, I started drawing and then I forgot I had it in my notebook. Yeah, same here.
How do you feel about joining Ruben in with your group? Ruben, Dennis, Faye.
What did you get? I don't know if that's right. I had it in my notebook, so. Yeah. I forgot I had it.
Fetch me!
Nope, that's make sure everyone in your group gets a turn to share.
Bye, Ginny. Thanks for not
No, I'm gonna go to work.
I know. I was like, oh, hell no. I was like, we're leaving on the squad.
All right, class. It seems like we've gotten as much sharing as we're gonna get. If you could get your clicker again, I'm just gonna ask, see if we've experienced any change through struggling through it, trying to piece it together, and chatting with your classmates. How confident do you feel about drawing the carbon cycle? Last chance for participation points. All right. Well, what I can tell you is that that exact slide will be on your study guide. So if you didn't catch all those terms, it's fine. I have a version here just to do one more review, especially since I don't like your book's representation. So last time we're going to try to use this crappy doc cam here. And if I'm being perfectly honest, I hope that did anybody see the man with the computer in class last time? Yes. He was breaking the rules. Anyway, no, he was here to just observe our class, and I used this hoping he would see how bad it is, but he was here late. Anyway, hopefully you can see this well enough. I think it's showing up pretty well. Here we have fossil fuels being burned in my factory. That says combustion up there. And so if you're asked to draw this, and maybe combustion isn't your preferred term, then you can just write burning or fire, you know. I'd like to see that you know that the smoky stuff of things being burned goes into the atmosphere pool. We have air-sea gas exchange. That's something I'm really hoping that everybody gets because I think it explains itself. The carbon dioxide from the atmosphere gets into the ocean and is used for photosynthesis. These are little phytoplankton in the fashion of Coskin discus, the diatom that many of you saw. This is a reservoir for organic carbon, and so are zooplankton. However, we have this step to demonstrate the biological pump. So the phytoplankton get consumed by zooplankton, and then through their waste, contribute to biogenic sedimentation, or is delivered thousands of meters down in the biological pump. Once that distance is traveled, if sedimentation is to occur, there are two main products of biogenic sedimentation. The organic carbon gets turned into fossil fuels after thousands and thousands of years. It's not like it gets there and there it is. Lots of time. The inorganic carbon could be made into limestone or calcium carbonate. There are many other rock types containing carbon. That's going to be our model though. And so if you're looking to connect this in a cycle, the fossil fuels would be mined and then end up here in the factory where the my sort of factory. where the combustion is occurring, but perhaps it's a misnomer to call it a carbon cycle. Maybe pools and reservoirs model would be more appropriate. All right, one thing that is not on here that I have had in previous iterations of our carbon cycle is the dissolved organic carbon. And I think it's great if you have that on yours. I think that's just a bonus, but I didn't include that in the main list of terms just because I think that this biogenic sedimentation part is more key, and often some people get zooplankton poop mixed up with phytoplankton pee. So if you're interested in wondering where that went, that's the answer. So that's great if you have it on your map. Let's keep following the carbon from phytoplankton over to zooplankton. Here we have another zooplankton friend. Remember that zooplankton also respire carbon dioxide that can then get exchanged, air-sea gas exchange. It can stay in the ocean too, and remember carbon dioxide, when it dissolves in water, makes it more acidic. Alright, we also have decomposition. This has previously been shown as a fish. It can be whatever. It is dead matter that's sinking. Decomposition produces carbon dioxide. It's very similar to respiration. There's that step. Lights are going back on. Comments? Questions? Wonderful. Oh wait, there's just a little bit more of a comment that I wanted to make about this. So, increased atmosphere CO2 is, I just wanted to take a moment to connect this with our discussion from the past few meetings. Increased atmospheric carbon dioxide, or carbon in general, causes climate change, and when that pool increases, this may change or stay the same, but whatever amount of carbon dioxide in the atmospheric portion is going to equilibrate here. So increased CO2 in ocean, oh goodness, reservoir, alright, so that's why we're refocusing on this as well, because carbon comes up a lot in our concerns about the Earth system. Lights are going back on. We're going to take a moment to really challenge you now. On the back of your note card, I'd just like you to take some time to consider how things might change in the future, given the increased carbon dioxide in the atmosphere, increased carbon dioxide in the ocean. How might things change? And for this, I'm going to ask you to pick a couple variables that you displayed on the front and predict their relationship. So again, I know this is a little bit of a challenge, but I think you can do it. The way that I'd like you to model this is with an if-then statement, or I think a plot would be just as nice to display your hypothesis. Daniel, could you please be quiet for the rest of this activity?
Just look at each other, but yeah.
So I have an example of something that might be relatable to what you wrote down. Maybe it'll be different. This one didn't directly relate to carbon when I first wrote it down, but increased carbon in the ocean means lower pH. So let's just say that for this model, pre-industrial pH 8.2, predicted 2100 pH 7.8. Your plot doesn't have to have this much detail. You could just write increasing or whatever metric fits with what you wrote. Then I have a response variable on this axis. And if you drew a plot, I would like to see that you predicted a pattern. And if you did an if-then statement, I would like to see that you also predicted an outcome. So very similar to when you read the article about light levels and toxin production in Pseudonychia, the diatom. Lower light levels, increasing toxin production. If I were to transfer this prediction into an if-then statement, I would say if pH decreases, then phytoplankton growth decreases. Because this is where pH decreased, this shows lower phytoplankton growth values. We'll just say 0 to 100 of these arbitrary units. If you were to assign this something, maybe cells per day. Yes, Vanessa?
Why would phytoplankton growth decrease if there's more carbon dioxide?
That's a good question. And for all of you, Vanessa asked why would that be? For your example, I'm leaving it up to you to think of reasons why. I think a lot of reasons are applicable. So my ideas about why you asked that question are because I've mentioned how on land, carbon dioxide is limiting for plants. Yes? It's a little bit different in the ocean. So in some cases, maybe that would be better if they had more carbon dioxide. But the small change in pH units actually means a big change in their chemical environment. So it might make them harder, make it harder for them to regulate what's going on inside of them when they have like more acidy material right outside their bodies. So it's not true for all phytoplankton. It might be true for some and not for others.
So
But
this is just like a hypothetical prediction?
yes, this is just a hypothetical prediction. Yeah. Does anybody need more time? Everyone's good. Excellent. Go ahead and pass that into the middle. Make sure your name's on it before you do. All right, our last topic of the year. Again, I think I'm going to turn the lights off so we can see this projection a little bit better. Here is a figure produced by the United States Geological Survey of sea level over the past about 18,000 years. And that's not that long in geological time, but it seems a long time. None of this stuff was there back then, all the gray buildings. So, I think I misquoted when I told some people that the Farallon Islands were 18 miles offshore. They're actually 30 miles from the Golden Gate Bridge. So that's a pretty far distance. We'll use that as a point of reference here. So about 8,000 years ago, the shoreline of San Francisco was down here, and then we go to 10,500, 11,500, 14,000 years ago, the shoreline was more than 30 miles farther out. So there was a lot more of San Francisco to be had. And then this last line out here, 18,000 years. Hopefully you recognize where we're at right now. We're about here on the peninsula. Here is the North Bay and Point Reyes. These lines here, or I guess you can't see them, but the white letters are for different tectonic boundaries. So there are a number of reasons this might change in the future. There are those boundaries, and this part of California is sliding past the other part. And then also, of course, as the title would suggest, sea level is changing. So what this trend is telling us from the past to the future is that sea level is rising, and that is a phenomenon that many scientists are observing in our current time. Here is a provocative image I found of San Francisco in the future. So here's the Embarcadero. We have Piers 23, etc. down here. This model is showing a lot of downtown underwater.
What?
Wait, no, I said it was the wrong place. This looks like the ballpark, doesn't it?
Yeah.
Yeah. Okay, so this is not over there. I think the Embarcadero is more over here. Still a lot of people without a home. Now, of course, something like this happens slowly, but as we mentioned with the king tides, the biggest tides that happen all year because of the alignment of the sun and the moon and the weather patterns, we're starting to see some surprising sea levels already. And so this sea level rise model is 2.25 meters, which is a few feet. To give some more context to this, I'm going to show a short clip from KQED Quest. I have a few questions I'd like you to try to answer while you are watching. And now this first one, why is sea level rise happening? In the first portion of the video, they just sort of gloss over it by saying scientists know why, but they give you some clues.
Are we turning this in?
No. You're going to write it down?
Sure. I'm ready. Ready when you are.
Okay. questions for you while you watch this short video clip. I think we are going to watch about 3 minutes of it and then maybe check in, possibly watch a little bit more. Lights going off again.
HD production.
You can't see it, or hear it, or even feel it. But all over the Bay Area, it's happening. Slowly, very slowly, along with all the Earth's oceans, San Francisco Bay is rising. The rise in sea level will affect everyone in the decades ahead who lives, works, or plays near the bay. Airport runways already are at or just a few feet above sea level now, as are many freeways, schools, hospitals, and homes. Scientists already know why it's happening. It's one of the most apparent impacts of climate change. The only real questions are how much it will rise and how fast.
We don't have a perfect crystal ball vision of the future. Scientists believe, with a great deal of evidence, that sea level is going up, and that it's going up increasingly quickly at an exponential rate. It could be as little as, and this is still a lot, 5 to 10 to 15 more inches over the next century. And it could be 60 feet over the next century. Now that would be a catastrophe, and we don't expect that yet. But the truth is, even the best estimates are estimates that are going to cause us serious, serious problems.
For people who make their homes in Alviso, a tiny working-class community that hugs the bay and San Jose's northern edges, coping with high water is almost second nature.
Alviso is kind of tucked into a marsh at the south end of San Francisco Bay. I'm walking by the South Bay Yacht Club here, and I'm looking more or less in the second-story windows. That's because the only thing separating the town from the bay is this levee I'm walking on. In fact, most of the town sits 13 feet below sea level.
Retired Fire Captain Dick Santos is chairman of the Santa Clara Valley Water District Board. He was born and still lives in Alviso, and like many longtime residents here, he's lost his home 3 times.
I remember my mother listening to the victim and said, "Come on, we got to get up, get in the dump truck. We all got to take each other out of here, get your stuff and belongings." And it was the water was